Hello, and welcome back to TECHFIX. Today, we're taking a look at one of the most talked about systems on the all-new Mack Anthem: automatic activation, automatic release, and automatic hold. If you don't understand how these systems interact, it can feel like the truck is making decisions on its own. But once you understand the logic behind it, everything becomes predictable. We're going deeper than surface level today. We're going to talk about who commands the decision, how air physically moves, how the electronic braking system influences the outcome, how the trailer system interacts, and how to approach this system with a diagnostic mindset. Everything we're covering today is backed by CBR 2443 and impact documentation. Let's get into it. On legacy trucks, parking brake control was primarily pneumatic and directly commanded by the driver. On the all-new Anthem, the goal remains exactly the same: secure the vehicle. However, now that goal is achieved through coordinated electronic and pneumatic systems working together. The electronic braking system regulates braking pressure electronically across the tractor and trailer, while the air production modulator manages compressed air production, drying, pressure regulation, and distribution throughout the pneumatic system. The dash parking brake control is simply the driver's request. The decision and execution are managed through system logic across multiple control units. This isn't a single component acting alone. It's a coordinated system response. Auto set occurs when the system determines that the vehicle must be secured, when the ignition is turned off, when the system detects conditions that indicate the driver may be leaving the vehicle, when the vehicle remains stationary for an extended period, or when system air pressure drops below a safe threshold. The system initiates parking brake application. Pretty freaking cool, huh? When this happens, air is exhausted from the spring brake chambers, allowing spring force to apply the brakes and hold the vehicle in place. An important detail many technicians don't realize is that if system pressure drops too low, the trailer parking brake is applied before the tractor parking brake. That's intentional stability logic designed to keep the combination secure. There is also no separate air tank dedicated solely to the parking brake. The parking brake circuits receive their air supplied directly from the APM distribution system. If overall system pressure becomes unstable, parking brake behavior will reflect that. When auto set occurs, it isn't just random, it's a protective response based on system state. Automatic release occurs when the system determines that the vehicle is ready to move safely. When the driver is seated, the engine is running, the transmission is engaged, and the accelerator input is detected, the system evaluates those conditions and responds by pressurizing the spring brake chambers to release the parking brake. This action is coordinated between the control modules and the APM, which physically directs air to the brake chambers. The system doesn't simply react to one input, it confirms multiple conditions before allowing the release. The result? A smooth and controlled transition from standstill to motion. Auto hold is an extension of hill start functionality in the electronic parking brake system. When the driver brings the vehicle to a complete stop and applies the brake pedal, auto hold maintains that brake pressure even after the pedal is released. Instead of applying a fixed pressure, the system calculates the required braking force based on vehicle load and road gradient. If the wheel speed sensors detect any movement, the system dynamically increases braking pressure to maintain standstill. When the accelerator pedal is pressed, the system gradually releases braking pressure to provide a smooth launch. If the vehicle remains stopped for an extended duration, the system may transition from surface brake hold to parking brake application in order to prevent brake fatigue and maintain secure hold. This is a protective feature built into the system. Auto hold is not simply holding pressure, it's continuously monitoring and adjusting. This system depends entirely on accurate sensor input. Wheel speed sensors provide real-time information about vehicle movement. The foot brake valve sends both an electrical signal and a pneumatic signal, ensuring redundance. Accelerator pedal position informs the system of driver intent. The EBS control unit processes this data and commands brake modulators accordingly. The EBS continuously calculates braking demand based on vehicle speed, load conditions, and driver input. The brake modulators, which are constantly supplied with air, act like intelligent relay valves that allow rapid and precise control of brake pressure. If system behavior appears inconsistent, The first step should always be verifying sensor inputs before replacing components. The APM is far more than just an air dryer. It controls compressed air production, regulates cut-in and cut-off pressures, dries and filters air, distributes air to braking and auxiliary circuits, and protects pneumatic circuits from leakage. Typical cut-in begins around 123 psi and cut-off occurs around 137 psi, though these values can adjust dynamically depending on vehicle operating state. Inside the APM are protection valves, solenoid valves that control parking brake and trailer air circuits, relay valves, and multiple pressure sensors. When the system commands auto set or auto release, those solenoids and relay valves physically move the air. The electronic command is translated into pneumatic action inside the APM. This is where the air authority lives. The electronic braking system is an electronically controlled pneumatic braking system. It regulates air pressure to the brake cylinders through modulators that are constantly supplied with air incapable of rapid response. If an electronic fault occurs, the pneumatic signal from the foot brake valve provides a backup path to maintain braking capability. This redundancy ensures that braking function is preserved even in the event of an electronic issue. The EBS is the intelligence behind brake force calculation, and the APM is the mechanism that supplies the air to execute those commands. There is no seat weight sensor driving parking brake logic. However, the seatbelt sensor is part of the logic chain. If the system detects conditions that suggest the driver is preparing to exit, automatic parking brake application may occur. Understanding this distinction prevents unnecessary troubleshooting. In a service environment, the system will behave exactly as designed. If the vehicle appears unattended or safety conditions are not satisfied, auto set will occur. This is intentional safety logic built into the Anthem to prevent unintended vehicle movement. If you're working on the truck in a bay and the parking brake keeps applying, the truck is not malfunctioning, it's responding to the condition it sees. However, there are times when technicians need the parking brake released to perform service work. That's where workshop mode becomes critical. Workshop mode allows technicians to temporarily prevent automatic parking brake activation while performing service. When workshop mode is active, the system will not automatically apply the parking brake simply because the ignition is cycled or certain safety conditions are detected. This allows the vehicle to remain released under controlled service conditions. To activate workshop mode, the electronic parking brake control lever is pressed and held while the ignition is moved to the off or accessory position. When done correctly, a confirmation message appears in the instrument cluster indicating service mode is active. That confirmation matters. If the message does not appear, workshop mode is not active. While workshop mode is enabled, automatic parking brake activation is inhibited, and standard parking brake alerts are suppressed. However, the state is temporary by design. Workshop mode will automatically exit if the parking brake is manually applied or if the vehicle is driven above approximately 18 miles per hour with the driveline engaged. Once either of those conditions occur, the system returns to full automatic protection logic. If an Anthem is in the shop and keeps applying the parking brake unexpectedly, the first question should always be, are we in workshop mode? Because if not, the truck is doing exactly what it was designed to do. The trailer brake system receives both electrical and pneumatic signals from the tractor and is supplied with air through the air production module. During trailer detection, the system may send a brief pulse of compressed air through the trailer air supply line. On certain air-actuated tandem slide systems, that pulse can unintentionally re-engage tandem locks. Updated software logic addresses this behavior. If tandem slide concerns are reported, verifying current software levels should be part of the diagnostic process before replacing hardware. Two Schrader valves are located directly on the air production modulator assembly. One valve connects the tractor parking brake circuit, and the other connects the trailer parking brake circuit. These are not random service ports. They are tied directly into the parking brake air supply circuits, controlled internally by the APM. That means when you manually charge air through one of these Schrader valves, you are pressurizing the corresponding parking brake circuit downstream of the APM's solenoid and relay valves. This becomes extremely valuable in specific scenarios. For example, if system air is depleted and you need to move the vehicle within the shop, maybe you're performing controlled diagnostics and need to charge a specific circuit, or if you're dealing with a recovery situation where normal compressor function is unavailable. These Schrader valves allow you to introduce compressed air directly into the tractor or trailer parking brake circuit. Now here's an important distinction. These valves are intended for controlled service and recovery use. They are not meant to bypass normal system logic during regular operation. Also, remember, because the tractor and trailer parking brake circuits are separate inside the APM, charging one does not automatically charge the other. You must know which circuit you are supporting. Knowing the exact location of these valves and understanding which circuit you're affecting can save serious diagnostic time. In a recovery situation, it can be the difference between waiting on a tow and getting the unit safely repositioned. That's real shop value. If auto set appears unexpected, verify system air pressure stability, confirm seatbelt status, check wheel speed sensor data, evaluate trailer status, and confirm software level. If automatic release doesn't occur, confirm engine state, transmission engagement, accelerator input, and adequate system pressure. Approach the system as an integrated network rather than isolated components, and always consider overall vehicle state when diagnosing behavior. On the all-new Mack Anthem, auto set is safety logic, auto release is conditional logic, and auto hold is dynamic pressure management. Remember, the APM controls air authority, the EBS provides braking intelligence, the sensors provide decision-making input. When you understand how these systems work together, you stop chasing symptoms and start diagnosing with intent. And when you diagnose with intent, not only are you fixing it right the first time, you're increasing uptime for our customers. That's TECHFIX. We'll catch you next time.